All right, welcome to the Virulent Vortex, a podcast in which we discuss infectious diseases from pathogens and molecules to populations, pandemics, and everything in between. My name is Jaap de Rode. I'm a biology professor here at Emory University. And with me is Nicole Hood, who is a student in the epidemiology program here at the Rollins School of Public Health. Welcome.
Thank you for having me.
Well, thanks so much for being on the show. So my understanding is that you are studying flu. So tell me a little bit why you're interested in flu before we talk about what you actually study.
Yeah, so I feel like the flu is such a dynamic virus and disease to study. You know, it's with us every year, every season. Every year we have a flu season. And so it is something that probably will be with us for many, many years to come, unfortunately. And so it's really interesting because it's very dynamic. The types of viruses that are circulating from year to year change, and they can change a little bit or they can change pretty dramatically. And in that case, that's when we have pandemics. And so I thought that it was really something that is important because we all could get the flu. It's not just, a small segment of the population that can get it, and it's universal. Everyone across the world can get the flu also.
Yeah, so you're interested in it as an infectious disease that can basically affect anyone. And that also changes from year to year. And a lot of people will know that because you need an updated flu vaccine every year.
Mm-hmm. Yeah, exactly. Yeah.
All right. And so what is it specifically that you study about the flu?
So there are a number of different things that I study, but one of the things in particular that I study is antibody landscapes in kids. And basically what that means is trying to figure out what sort of antibodies our bodies will produce when we encounter the flu. So whether that be through infection or through vaccination. So for antibodies, they kind of serve as a correlate of protection against the flu. And so when we're looking at antibodies, we can kind of see whether they will potentially have a lot of protection against the flu or not when they encounter it in terms of an infection.
So you mentioned antibody landscapes. So antibodies are the molecules that immune cells produce against infectious diseases or viruses, in this case, flu. And so when you say landscape, do you mean a landscape, such as the state of Georgia? Or are you talking about the specific antibodies, how they change over time?
Yeah. So that's a great question. I'm talking about the specific antibodies and how they change over time. And so basically, if we have people that were following from, let's say, birth till maybe 5 years of age, we can collect samples to see what is going on with their antibodies at those particular points in time and see how the antibody levels change over time and change when they encounter different types of flu viruses versus, other types of flu viruses.
Yeah. And why is that important?
That's important because it really helps us understand who might be most vulnerable to the flu, because we have basically years in which we have different viruses circulating, as I kind of mentioned before. And so if we know when someone was born, for example, we might know what sort of virus they're exposed to. And so we can kind of put them in birth cohorts. And if we kind of know what birth cohort a person is in, and we can figure out sort of what their antibody levels are based on when they're born, we can see what sort of level of protection they might have against a circulating virus that might pop up in the future or this year or this season.
So is the idea that you can look at someone's blood? I'm assuming you're looking at individual's blood. There's kind of like a signature of the viruses they have encountered in the past?
Mm-hmm. Yeah, exactly. That's a great way to put it. So basically, by looking at people's blood, we can kind of see some sort of correlate, which is the antibody, that gives us an indication as to whether they've perhaps encountered maybe not the same virus as what's circulating right now, but perhaps a similar virus. And we can also just test for viruses that they may have never possibly encountered and see whether they have some sort of a response to that. And that could help for the future, what viruses might appear in the future as well.
I see. So how does vaccination come into this? Because you're basically looking across individuals and you can see you have had these viruses, you have these, but you're presumably still going to vaccinate them for whatever viruses may come this year.
Yes, exactly. So we do want to still vaccinate because even if you have had prior exposure and so have some sort of immunity, we would assume, to the virus that is circulating this year, we still think it's important to vaccinate because you can get an extra boost from vaccination that can hopefully provide some extra protection against the virus that is circulating. And in general, it could potentially help for future viruses that may may not necessarily be similar to the one that's circulating in the current year.
Yeah. Okay. And so what would you say is maybe the most surprising finding of your research so far?
Oh, so I guess one of the things that we're noticing in the data, which is very preliminary, so there's still a lot more work to be done, is that we're looking at viruses that people have definitely been exposed to, and then viruses that we know that they definitely were not possibly exposed to. And so we're tracking their antibody landscape, as I mentioned, over time to see what the patterns of antibody rise and fall are in response to infection or vaccination, and then after some sort of period of time from that infection or vaccine to see what's happening with the antibody levels. And we've seen that even if you haven't encountered a specific virus of the flu before, we're kind of seeing similar patterns of increase and decrease compared to the ones that you have seen before. And so even though you might have higher levels of antibody for the virus that you have seen before, and then lower levels of antibody for the virus that you haven't seen before, that general trajectory is kind of the same, if that makes sense.
So how can that be? Do you have an explanation for this?
Yeah, so I don't think I have a full explanation for this. A lot more needs to be done. But I think generally speaking, we have a baseline level of immunity because we've all encountered the flu by a certain year of age. And so when we encounter this virus that we haven't been particularly exposed to, I think it's just a matter of the magnitude of the reaction to the infection or the vaccination.
So with all this research that you're doing, what do you hope to achieve in terms of making healthier people or making people better?
Yeah, so I think just generally this will help us give a better understanding of how we interact with different types of flu viruses, ones that we've seen before or pretty similar to the ones that we've seen before, ones that are fairly different. And I think this helps us going into the future to kind of give an idea of who might be most vulnerable in terms of birth cohorts that I kind of mentioned before, which kind of translate to ages roughly. And then also to perhaps better target what our viruses will be in the vaccines, as well as perhaps allow us to implement different prevention measures when we do think that there might be a season in which there is a pretty different virus from the one that we've seen circulating around before.
All right. So we have talked a lot about the landscape of antibodies, which is kind of the signature of antibodies over time, but that's not the only thing that you study for flu. So tell us about the other thing you're doing.
So I kind of mentioned it before, but I'm also studying birth cohorts. And basically these are people that have been born at times in which we think similar types of viruses were circulating. And so we think that if they were exposed to the same type of virus, they were likely first infected with that type of virus. And we think that that first type of virus that they were infected with could actually be really key in terms of long-term immunity and how we respond to subsequent infections or exposures to the flu. And so this has been a really interesting area of work for me because the phenomenon is kind of known, but the details of how it works isn't exactly quite as clear. And so I think it's been a really cool place to kind of sink my teeth into.
All right, but that's very interesting. Thank you so much for sharing your research with us.
Thank you for having me.